Okay, let's take a look at some important ideas from the challenge problems from Unit 3, considering Module 9, 10, and 11. So I'm going to talk through some of the important ideas here. So in this first situation, we're talking about a sample that was collected. And since we're talking about a sample of 103, and we're not considering the sampling distribution, right? Just this description here is a situation where the information or data is not normally distributed, it's skewed. So if you look at thinking about what the variable is, right? The variable is quantitative, an average weight, right? And so when you think about the distribution of how weight was gained, you can see that 75% gained 1.1 pounds, 20% maintained, and about 5% loss. If you think about that, think about how that, if you had an x-axis with weight gain, loss, right? Negative, positive, 0, you would see that it's not normally distributed, right? It's kind of skewed to the 75% in one space, and then a little bit of a weight gain and a little bit less of loss. So it's not normally distributed. Now, when we're talking about the sampling distribution, when we look at the sampling distribution here, if we were to sample, right, college freshmen over and over again, because of the central limit theorem, and if you use the samples of 103 over and over again, then we would assume that it would be a normal distribution, and then we would use, because of the central limit theorem, we would use the one sample t-interval method, which I then show here. And the most important thing here, since it's a t value, is that you're using the appropriate t value, right? The critical t value you'd use to calculate your margin of error, right? 5.7 is your sample, right? It's your sample mean, and that becomes the center of that confidence interval. And so that's what we would have here. And notice the width of each of these. Notice that the 90% confidence interval, I'm less confident, which means my estimate is smaller. I'm less likely to be correct with my estimate. A 95% confidence interval, it's wider, has more value, and that has to do with the test statistic. Okay, let's move on to number 2. So looking at these are given confidence intervals, right? These are already calculated. And so these are, again, hypothetical confidence intervals. It's an estimate. Remember, confidence intervals are estimates of the population. So in this case, we're trying to estimate the population parameter, the mean, right? Commute time. And so remember the sample mean. When you construct a confidence interval, it always starts with the sample mean, and that will always be in the center of those values, right? It's directly in the middle. And then I think what I've seen people do in their homework is they add these two numbers up and then divide by 2. And then that gets you your center value or your sample mean, right? Because you have to remember, what is a confidence interval? It's constructed from a margin of error that is centered on the sample that you collect, right? And that would be the sample mean or proportion. In this case, it's the mean. And that same conversation that I had earlier in the previous problem regarding to the width, how do I know which one again? If I'm less confident, then my estimate's going to be smaller, right? Because remember, I'm trying to estimate the population. So if I have a smaller estimate, I'm less likely to be correct, which means I have less confidence. Let's continue on. Number 3. We're at number 3 now. Here we're trying to estimate a sample size needed. Now, in the real world, many times when we're conducting a study, I don't know how many people I need to interview, sample, put into the experiment. And what that depends upon many times, it's going to depend upon what margin of error, right, that you want. And then how confident you want to be with your estimate or your conclusions. And so in this case, we want to be within a half a mile, our margin of error from the population parameter. And we want to be 95% confident with that. And so given the population standard deviation, we can then use to estimate, right? And you end up with a decimal answer. And since we're trying to estimate the number, in this case, not people, but cars, you can't have 100. If I need 131.02 cars to get to this margin of error with this level of confidence, I can't say 131, right? I'm not going to round down because then it's not enough. I don't have enough. So you round up. So 132 ensures that you're going to have enough to meet these requirements that you've set out for yourself. Continue on, number 4. Number 4, we're looking at do we have sample sizes large enough? And so in this case, as I have this set up here, you can see the calculations. And really what's important is to acknowledge that I cannot construct a confidence interval if my sample sizes are not large enough. And large enough is connected to the idea that we only can use all these procedures if the data we're dealing with, their sampling distributions, are normally distributed. And so that's what we're checking here. And this is the technique we use to check to see if samples are large enough when we're dealing with categorical or qualitative data because of proportions. And this is what we would use here. Okay, large enough is different if we have, we're talking about quantitative variables in means. Okay, number 5. Here you're just going to calculate this is going through the process of calculating a confidence interval. And so the point estimate is your sample, right? Sample proportion in this case. Your margin of error key is this value we're using here, which would be a z-score, z-value. Not a z-score, but z-value, and then the level of confidence, and that's where that comes from. And we've shown you using StatCrunch how to get that, or the list of values that is there and available as you get there. And then once you have that, you can go ahead and construct it and make sure you know how to state it, right? This is the conclusion we can make about a confidence, and it's very specific about what we can say around that, right? So if we conduct this sample over and over again, and we did it multiple times, right, we have this level of confidence that the proportion, the population is between those two numbers. Would a 95% confidence be smaller or larger? Again, this goes back to our explanations before. 95% are going to be larger, right? We'll continue. Number 6 again is estimate of sample, your sample size, and in this case here, we're looking at a different formula because this is a proportion. Okay, we're asking for proportions. We're estimating how many people, but the variable, right, in this time is qualitative or categorical, so it's a proportion, so it's a different formula that we're using. We still use a z value, but again, once you have your value, you have to round up. And then this is to ensure, right, we're choosing the level of confidence and what error we want. And again, that's the idea that in the real world, we never know how many people do we need to interview, test, including the experiment. It all depends on your margin of error and how confident you want to be with that. And then lastly, this number 7 here, you can see my response here. Again, I really want you thinking deeply around, like, what tests do we use, right? This leads to the future modules. Which methods do we use? And those methods are determined by the type of variable that we're dealing with, whether it's qualitative, categorical, or quantitative. Each of those brings a different types of question, a response, right? And so you want to keep that in mind, is that's how we choose to our methods. And so that's what we have here.